This homework assignment is about 3 topics that will reoccur many times throughout this course. 1. Measuring with non-standard units. 2. Rescaling quantities. 3. Estimating the magnitude of errors. Later, we'll be applying these topics to statistical objects, instead of to real objects and shapes. For example, if the spinner on the left is fair, then a graph of its results should look like something close to the graph shown on the right. That is, there should be approximately the same number of counters in each column of the graph. So, which of the graphs below is closest to, or farthest from, this expected graph? This is also a problem about distances, but, for now, we'll focus on length and distances for objects that are easier to visualize. For example, in this activity, you'll be measuring lengths and distances on maps, or in photographs, or on streets and walkways near where you live. For now, we will focus on situations where distances are easier to visualize. For example, in your homework assignment for today, you will be asked to measure the distance from where you live to the building where your class is held for this course. Then, you will be asked to estimate which method is likely to be most accurate. Or, in another problem, you will be shown several photographs of a newborn baby. And, you will be asked to create a stick figure, like the one shown here, to show the sizes of the baby's various body parts. Then, you will be asked to create a scaled-up version of the stick figure, so that it will be the height of an adult. Then, your task will be to identify which of the baby's body parts is most out of proportion compared to an adult. Here is the first photograph that gives a clue about the size of the baby's various body parts. The picture shows a newborn baby being held by her father. And, a clue is that her father's pointer finger is 3.5 inches long from the crease on his knuckle to the tip of his finger. Here is a second clue. The baby is now being held by her grandmother. And, her grandmother's thumb, from knuckle to tip, is 2.5 inches long. Once you have made a scale model of the baby, you should be able to identify which parts of the baby are most out of proportion compared with a similar model for an adult. Similar distortions also could be identified for different kinds of transformations that could be applied to the stick figure. And, when we start to compare and combine data of different types, similar distortions also will occur for different kinds of data transformations. For example, as these animations suggest, graphs will be helpful for identifying distortions in data. Throughout these animations, notice how changes in the graphs correspond to changes in relationships between the two sets of data. Just by looking at such graphs, you often will be able to identify how much, and in what ways, different kinds of transformations distort information that you've been given.